Good day. We'll turn our attention to another example that still deals with tree diagrams, but now with conditional probability. So let's get right into it. A golfer observes that when playing a particular hole at his local course, he hits a straight drive on 80% of the occasions when the weather is not windy, but only on 30% of the occasions when the weather is windy. Local records suggest that the weather is windy on 55% of all the days. So A showed that the probability that on a randomly chosen day the golfer will hit a straight drive at the hole is 0.525. So let's start where we start with identifying the events taking place. So what starts is the weather being windy or being calm. Then the calmness will determine whether the golfer will attempt the straight drive or not, or will hesitate. So let's illustrate that idea. We'll start by checking, is the weather windy? So that's W, or not windy, the complement. So the probability that the weather is windy is 0.55, is just that 55% as a decimal. And then the other one is going to be 0.45. Remember, probabilities on connected branches should add up to 1. Then after that, we have to remember that when the golfer observes that when playing a particular hole at his local, he hits a straight drive on 80% of the occasions when the weather is not windy. So when it is not windy, he can attempt a straight drive, or sometimes can hesitate. So that would be the complement. Attempting the drive, not attempting the drive. So the probability of attempting a drive, given that it's not windy, that's 0.80, and then the hesitance, the chances for that are 20%. And then given that it is windy, when the weather, so the statement was continued, when the weather is not windy, but only on 30% of the occasions when the weather is windy. So when the weather is windy, when it is windy, you attempt the drive on 30% of the occasions. So that's 0.3. And then you will not attempt on 70% of the occasions. So that's our tree diagram. So let's now attempt that question. So it says, show that the probability that on a randomly chosen day the golfer will hit a straight drive at the hole is this, on a randomly chosen day. Now on this day it can be windy or not windy, right? So let's account for both cases. So we'll say the probability that the golfer will attempt a drive, right? This will happen whether it was windy or sometimes even when it is not windy. So in both of these cases, the golfer attempts a drive. So let's substitute. So it's this way or this way. Remember, so in the language of probability, or is represented by a plus, and then and is represented by a times. So let's follow the branch when it is windy and he drives. So that's 0.55 times 0.30. That's the first scenario. The second scenario, we have not windy and then the attempt of the drive. And then if you punch this in the calculator, you should get the answer. So it's 0.55 times 0.30 plus, for the alternate route, 0.45. So it's 0.45 times 0.80. So punch that in the calculator, you get 21/40, which is 0.525 as given. So we've successfully shown that. Now for the next part, we asked, given that he fails to hit a straight drive at the hole, calculate the probability that the weather is windy. right? So there we have the condition there. So how do we go about this? We are saying, given that he fails to hit a straight drive at the hole, so he attempts and he fails, so that will be represented by D complement, failing the attempted, failing to sink the attempted straight drive. And then so we want, given that he failed the attempted straight drive, calculate the probability that the weather is windy. So this is how we build it, right? And then our probability there. So for us to find this, we should say the probability that it is windy and it does not sink it over the probability that he fails to sink the attempted straight drive. So remember that in this previous part, we found the probability that he will sink the attempted straight drive. So the complement is just 1 minus that one. So let's find that. Probability of the complement of D is simply 1 minus probability of D, which is the 1 minus 0.525. So